Good morning. I hope you're doing well. This is a video about section 5.3 for MS111 and all other algebra online courses. So let's switch over to my Prezi and get started. The first thing we're going to talk about is how to apply properties to logarithmic functions. Let's start by looking at the definition. Remember that the base is greater than 0 and the base cannot equal 1, and a is greater than 0. So the bottom line that you have to always remember when working with logarithms, logarithm is an exponent. So by definition, the logarithm base b of a is a number k such that b raised to the k is equal to a. So let's take a look at what this really means. When you're trying to find a logarithm, if you look at log base 2 of 32, you should be asking yourself 2 to the what equals 32. 2 to the 5th power equals 32. So the answer to the problem is log base 2 of 32 is equal to 5 because 5 is the exponent. Now I'd like you to try these two problems. Pause your video and hit play after you complete them. Do your solutions look like this? Log base 5 of 25, your brain should have asked you, 5 raised to what power will equal 25? We all know that 5 squared equals 25, so the answer is 2. Log base 5 of 25 is equal to 2. Now log base 3 of 81, your brain is asking you, 3 raised to what power is equal to 81? 3 to the 4th power is equal to 81. So the exponent is 4, and since a logarithm is an exponent, we know that log base 3 of 81 is equal to 4. Now, one other thing to keep in mind is common logarithms. Common logarithms are base 10, and mathematicians typically get lazy and do not write the number 10 in the base spot. So keep in mind that if no indication is in the base, that it is implying that it is base 10. Now, what about these last two properties we're going to look at? Log base b of b is equal to 1, and log base b of 1 is equal to 0. Do these make sense to you? What if I said b raised to the first power is equal to b, and b raised to 0 is equal to 1? Those make sense, and that's exactly what the logarithms are saying above. Let's take a look at our next task. How about a little dose of cuteness? This is a picture of Newton enjoying the sun while sleeping on the bone that he's trying to hide from his brothers. Convert equations from logarithmic form to exponential form. Logarithmic form makes sense. That is going to have the word log in the equation. So the function g of x is equal to log base b of x. Then we know its inverse is an exponential form. So the inverse notation of g of x is equal to b raised to the x. And likewise, if we convert equations from exponential form to logarithmic form, we start out with the function of x is equal to b raised to the x power, and the inverse will be a log form. So the inverse function of f is equal to log base b of x. And in the red, you can see where I gave you an example. If the function of x was equal to 5 raised to x, then the inverse function is log base 5 of x. You'll have plenty of practice in your homework problems to continue working on converting logarithmic to exponential and exponential to logarithmic. Thought you would enjoy seeing what Mac's doing during break. He's taking naps and snuggling his brother Willie. He misses all of you and hopes that he'll see you on campus in the fall. Next, let's look at how we model authentic situations using logarithmics. So one of the things you may have been familiar with is oftentimes when we have an earthquake, we hear of the Richter scale. And the Richter scale R is an earthquake is a measurement between the amplitudes of the waves. So we have a formula that says the Richter scale is equal to the log of A over A sub 0, where A is the amplitude or the maximum value of the wave, and A sub 0 is the reference amplitude, or which is the smallest wave. So let's try to figure out what the Richter scale would be for two different earthquakes, one that took place in 1906 and one that took place in 1989. We are going to find the Richter scale for both earthquakes, and then you're going to continue working to find the ratio. So the original equation, R is equal to the log of A over A sub 0, is how we're going to try to find the Richter scale for the 1906 earthquake. In the problem, it said the amplitude was 2 times 10 to the 8th times the reference amplitude, A sub 0. So that is our numerator, 2 times 10 raised to the 8th times A sub 0, all divided by A sub 0. We know that A sub 0 over A sub 0 will cancel to 1, leaving us log of 2 times 10 to the 8th. When you plug this into your calculator, log parenthesis 2 times 10 to the 8th parenthesis, you should get an approximate Richter scale of 8.3. Now, I'm going to leave the 1989 problem, which is 8 times 10 to the 6th times A sub 0, for you to figure out the Richter scale for the 1989 earthquake. See your book, page 282, which will show you the complete details. Let's talk about some important reminders. You need to be checking your Aquinas email at least daily, and I recommend more than that. You need to log into Course Connect at least every other day. You need to manage your time now that you have online classes, and you need to watch for the due dates and certainly do the work. How to ask questions and seek help. You can see by this picture that I have virtual office hours in the chat version next to your email. Click on our group discussion and feel free to ask questions there. Office hours will remain the same as when we were in session, 10:45 to 1:15 on Mondays and Thursdays. You can also call or text the 616-888-1539 anytime, like you have been able to all of semester. Lastly, just want you to know that Dr. Mack and I will be praying for you and your family and your health and your patience as we continue to work online. Also, please never feel alone. Reach out to someone if you need help. Everyone at the college is still working hard to make sure that we can provide you with the best education possible. For now, that's all I have. I'll have 5.4 video up shortly. If you need anything, please reach out.